So we have, as I mentioned, we have the test for Thursday. And so I went over the solution to the quiz after I gave it, right? And I posted a correction to that. So the thing I did wrong, and I'll review it again here just to make sure. It's also a good example to go over again. So this was problem 4 from quiz 3. So the problem as stated was x squared minus 16 over 2x squared plus 6x minus 8, right? I'm supposed to multiply that by 4x squared minus 4x divided by x minus 1, all right? And the mistake I made was when I copied the problem down wrong, I neglected the x here. All right, so when I neglected that x, it changed the problem a little bit. So let's just go through it with the correct thing. A lot of you got this right. So what I'm going to do is just to factor whatever I can. So that's x minus 4 times x plus 4, right? Times 4 times x squared minus x, all right? And then divide by, I'll factor a 2 out, x squared plus 3x minus 4, and then x minus 1. So any questions about my first step? No? Notice that there's a 4 over a 2, right? So we can simplify that to 2. And then I'll keep what I had, x minus 4 times x plus 4. And then that's x times x minus 1, right? And then this factors to x plus 4 times x minus 1. And then there's still that other x minus 1 factor there, right? And so now I've completely factored the numerator and the denominator, and then we can see, what's that? Oh. So we can see if anything, cancels, reduces. Obviously, there's a x minus 1 factor that cancels out, right? Like this guy and this guy go, and then, also this x plus 4 with this x plus 4, right? And that's pretty much it. So I'll just write it again to clean things up. So here's the answer, 2 times x minus 4 times x over x minus 1. So now a lot of you gave me the answer 2x squared minus 8x over x minus 1. Or some of you gave me, or some others of you gave me the answer 2 times 2x times x minus 4. I mean, anyway, these are all perfectly fine answers, The point is you've already canceled as much as you can. And you can either leave it in factored form or multiply it out. Either way is fine with me. Any questions about this? Any questions about your homework? So you guys are all done with all the homework? No? The homework is most helpful if you do it before the test, right? So, have you done the homework relevant to test 3 already? Oh, okay, so that's mostly what I'm talking about. But yeah, all the homework, I did open all the homework, right, up till December, whatever it was. Not too late, like December 2nd or something. So but not the homework that's for test 3. The test 3 homework needs to be done before test 3. All right, but the homework before test, before test 2, that stuff I opened up again so that you can do it until December 2nd. All right. So if you missed something from before, you can go back and fill in if you want. And then once that final date that the homework is due for comes, then at that point I will go and find your points in Blackboard and transform, points in my math lab, and I'll transfer them over appropriately weighted into the blackboard. If I remember right, there's something like 560 my math lab points, I'm guessing, and so like, you know, I have to, and then what percentage, how many points in your syllabus did I give you for homework? It wasn't 560, right? It was, I can tell you in a second here. I don't remember it. I have it memorized. Give me a second here, I'll tell you. So I think if I remember right, it's something like divide your my math lab points by 3. That's the number of points that you've earned for the course. It's not that though. It's something like that. And I usually when I look at all the homework, I'll pick the few people who have like the absolute highest scores, and I'll give them some bonus, and use that kind of as the weight. So if like, you know, if the person with the absolute max score on the homework got, say, let's just for the sake of discussion, suppose they got 560 points in my math lab, then I might make like 540 points, 100% of the homework score. So the people who actually did 20 points more get a little bonus for that, something like that. That is typically what I do, just to let you know. Let's see here. Well, I'm looking for Google Chrome, but I foolishly made Google Chrome the default like software to open a particular file. There's like 30 Google Chrome icons on my desktop. I can't see the actual program. Let's see here. Here we go, Blackboard. Bear with me here for a second. So in the syllabus, I say homework is 150 points, right? So, so yeah, I think, and so the question is how many total points there are in Blackboard. I mean, not in Blackboard, but in my math lab. I forget off the head. I'm remembering 560, but I'm not 100% sure on that. If it actually is 560, that means I'll probably divide by, you know, 540 and multiply that by 150 to get the number of points I put into Blackboard, something like that. So anyway, let's just say this. If you got 100% of the homework right in my math lab, you probably end up getting like, you know, a 10-point bonus on the course, something like that. Right? Something like that. Not 10 percentage points, but like that's 10 points out of 1,000. That's like a percent bonus. Yeah. Anyway, enough about all that. Do you guys have any questions about this material? Nobody? Let's see here. Well, I think we did a lot of radical problems last time, right? So I think a good use of our time might be to do some more long. I'm trying to remember. Seems like quiz 3 is missing something from the material we've covered, isn't it? What was it missing? Let's see here. Let me take a look at something. So, no, that's not it. let's see. So the kind of problems we have to worry about for test 3, we have to find the domain of rational functions, right? That was the first question. Simplify exponents, right? Simplify rational expressions. Like I have up on the board there, right? Rationalize denominators. I'll work a couple more of those. We haven't done that in a little bit. And then solve rational equations. I feel like I'm missing something, guys. That's what's bothering me here. No, that's it. All right, so example 2, let's rationalize. So here we go. We have 1 over 7 plus the square root of 3. So what should I do to put that, to rationalize that expression, right? Example 3, and I may not have done one of these in class yet, but this is actually relevant. 1 plus 2 times 3i, where I squared is equal to minus 1, right? In other words, you could write I as the square root of minus 1. So how do we rationalize the expression? Just remember, we multiply by what? The same thing, but with the plus changed to a minus, right? So you take this and multiply by 7 minus the square root of 3 over 7 minus the square root of 3. And that gives us what? 7 minus the square root of 3 divided by what? 7 times 7 is 49, right? And then plus, root 3 times 7 minus 7 times root 3 minus the square root of 3 squared, right? Notice that these guys cancel. Let me cancel this marker. That was very, very bad. I need a taller room. Like, I'm always going to hit the, I don't know, excuses. See, I have actually gotten markers into trash cans before. It has happened, just never in this building so much. So that's 49 minus, square root of 3 squared is what? Just 3. So 49 minus 3 is 46. So what we have is 7 minus the square root of 3 divided by 46. And there you go. We have rationalized I said rationalized expression. I should really say rationalized denominator. That's what I'm talking about here. I mean, there's still a radical. There's still a radical in the expression, right? It's just moved to the numerator now, right? And you can't really get rid of it. It's there somewhere. I don't think we've talked about this much in here, but I should mention, you can do the same thing with complex numbers, right? So if you have a complex number that's written as like 1 over a complex number, we can make it into so-called Cartesian form by multiplying by 2 minus 3i over 2, same trick. And that gives us 2 minus 3i over 4 plus 6i minus 6i minus 3i squared. Same trick, actually, right? And the 6i and the minus 6i cancel, right? And what we're left with is 2 minus 3i over 4. 3 times 3 is what? 3 times 3 is 9, right? So that's a 9i squared there, my bad. But I squared is minus 1, so that's plus 9. So what do we have? We have 2 over 13 minus 3 over 13 times I. So this is what's called the Cartesian form of 1 over 2 plus 3i, right? if you wanted to plot that number, the complex number in the complex plane, you kind of need to know the Cartesian form, right? Like, if I asked you, to plot 1 over 2 plus 3i in complex plane, that's kind of tricky. But if I ask you to plot that in the complex plane, well, it's a simple matter. So the way the complex plane works is you go, the imaginary axis is up, and the real axis is over. Essentially, it's just this: a plus ib is equal to a comma b. So we're at 2/13 comma minus 3/13, so that's like, 2 over, and so to my choice of scale, this is where it is. Now, this is not on the test, right? Because the complex plane is not part of this course, right? So, as far as I remember. So I'm just giving you a reason that you might be interested in doing this calculation, is because if you did, you can actually visualize where this 1 over 2 plus 3i number is in the complex plane. It's here, right? So, another example of these, because I think we need a little bit more practice. This time I'll make it a little bit uglier. Example 4. What if we have 3 plus 2 square root of 7 over 1 plus the square root of, let's say, 11. Well, maybe not 11. That's too much like the other one. I'll go with square root of 3. There we go. And the instructions are, again, to rationalize the denominator. So what should we do? Yeah, what you say, multiply by what? 1 minus the square root of 3 over 1 minus. We always have to multiply by the top and the bottom, the same thing, because we're just multiplying by 1, right? Now it's kind of a pain, because we actually have to kind of like FOIL this out, right? So we've got ourselves a 3 minus 3 root 3. That's the 3 times these two things, right? And then we have plus 2 root 7 minus 2 root 7 times root 3, right? And that's all divided by 1 plus root 3 minus root 3 minus the square root of 3 quantity squared. So this time, the denominator actually ends up being negative, right? See what happens? The root 3 and the minus root 3 cancel as we, by our design, right? That was the whole reason we multiplied by what we did, is to make that happen. And upstairs, we've got 3 minus 3 root 3 plus 2 root 7 minus 2 times the square root of 21, all divided by minus 2. So there you go. And of course, you could simplify this if you wanted to, right? A little bit. I mean, it's debatable, folks, whether or not this is simpler. But we could rewrite this as minus 3 halves plus 3 halves root 3 minus the square root of 7 minus the square root of 21. This is another good way to write the answer. See, if you've got division by 2 across a sum, then it's the same as dividing each thing in the sum by the minus 2, right? So. do an example of a rational simplification. Suppose you're faced with the problem of simplifying, let's see here, 2 over y plus 5 over z all divided by, and this is from section 5.4 if you're wondering, 1 over y minus 4 over z. So we want to simplify this. What should we do? What do you want to get rid of? You want to get rid of the fractions, right? How can we clear out those fractions? What's a good thing to multiply this by? What's that? No? How about this? If I multiply it by y over y, that's pretty good, because then when I distribute that through, what's going to do? Well, it's going to kill the 1 over y fractions, right? But I'm greedy. I want more than that, right? I want to kill the 1 over z as well. So how about also multiply by z, top and the bottom? In other words, yz is the least common multiple of y and z. So we like to find the least common multiple when we're taking a sum or difference of fractions and multiply by that to get rid of that common, get rid of all the denominators. So what happens? What do we get? We get, I'll write it out. So it's 2 over y times yz, right? Plus 5 over z times yz divided by 1 over y times yz minus 4 over z times yz. And then how do those simplify? Tons of cancellations, right? So like the y and the y cancel here, the z and the z cancel, right? Z and z cancel, y and y cancel. What are we left with? 2 times z plus 5 times y divided by z minus 4 times y. Hey, that's right, it's done. Thanks to the truck for the commentary. That's good? Can you guys do this on the test? Thursday? Yeah? Is there hope? I think there's hope. Let's look at one that's a little bit more nuanced. So here the question is to simplify again. And let's suppose we're looking at 1 over x squared minus 4 plus x over x minus 2, and we wish to simplify this. So in order to add those fractions, what do you need to do? You need to find a common denominator, right? So what do you guys think? Yeah, how about x? Let's look at x squared minus 4. What's that? That's x plus 2 times x minus 2, right? So, hey, look, we've already got, so this x squared minus 4 has already got an x plus 2 and an x minus 2 in it, right? So we already have the x minus 2 in common here and here, right? So to make the second fraction look like the first, what do we need to do? We need to create an x plus 2 in the denominator here so that it matches up with the denominator of the first fraction, right? So what we should do is the following. We should multiply by, we're always multiplying by 1, right? If we're just trying to, modify the expression. So here, multiply by x plus 2 over x plus 2. If I do that, then both of the fractions will have a denominator of x squared minus 4, right? So we get 1 over x squared minus 4 plus x squared plus 2x over x squared minus 4, which gives me x squared plus 2x plus 1 over x squared minus 4. If you don't mind, I decided to write the x squared plus 2x first because I wanted you maybe, I was hoping something popped out at you as you look at the numerator there. Can you simplify that? Well, first of all, this would be a totally fine answer, right? Given the instructions that I've said so far, I said simplify, right? Have we simplified it? Yes, I think that's pretty clear. That's simplify. Now, what if I added instructions? What if I said leave your answer in factored form, right? Yeah, then we need to factor the numerator and factor, right? So in factored form, completely factored form, what is this? X squared plus 2x plus 1, what's that? X plus 1 times x plus 1, right? So that's x plus 1 squared divided by x plus 2. I'm just going back to x, what we already know. So this would be the answer in completely factored form. Right. So it just depends on the instructions, right? If I just said simplify, I'd take either what I've boxed in red or in purple as the correct answer. If I said completely factored form, then I would hope that you would give me the completely factored form. But suppose you didn't, I'd still give you like a lot of partial credit for doing the other thing. The main thing here, the difficulty, is making the common denominator, right? So, we're going to have the test Thursday, right? And then what's going to happen? Thanksgiving break, right? So you're all going to go home and like study all of the things that you missed, right? And spend your whole Thanksgiving thinking about this class. I'm guessing, no, probably not, right? You're probably going to go home or wherever and spend time with friends and stuff and not think about school so much, more likely, right? But then after that, you're going to come back, right? And we're going to have like a half a week class, and then the finals will be upon you, right? So it's really not too long from now that you're going to be actually faced with the final exam for this course, right? When is the final exam for this course? Do you know? Did I say it? Did I put it in the syllabus? I can't even remember. My bad, Let me look here. Is it month? I always forget, so I searched UWA. You can find out the final exam times for all your calendars. It just search like UWA final exam schedule, and you want to look for the one that's, let's see, where are we? 2021 to 2022, right? Let's see here. Spring 21, that doesn't help me. Summer, I don't care about that. Fall. So we're what? A Tuesday, Thursday, 11 to 12:15, right? So let's see here. Yeah, 11 a.m. All classes scheduled at, where are we here? All classes scheduled, it says, all classes scheduled at 11 a.m. I'm getting Wednesday, December 8th as the final exam period for us, if I'm reading this correctly. Do you guys agree? So it says on Wednesday, December 8th, 2021, all classes scheduled at 11 a.m. That would be us, right? The final exam is 11 to 1 p.m., December 8th. So. And in case you didn't know, I mean, that final exam will be in this room, right? Unless there's some, like, modulo some incredible event like this building burns down to the ground over Thanksgiving break or something. It's probably not going to happen. But I certainly have no plans. If it does happen, I have no plans. Just saying. All right. Now maybe I need to edit this video. I don't know. Anyway, so that's the final exam, Wednesday, right? So that's like, goodness gracious, that's super late in the exam week, isn't it?
It's a Wednesday.
Yeah, that's the last day of finals. Yeah. Well, there's a Thursday makeup day, but we try not to use that, right? This is Wednesday. So, all right. But anyway, in this room. And that final exam will be comprehensive, right? So as you think back on the course, is there anything that you'd like me to review? Because I think we have a little bit of time today to just start our final exam review. Since you guys don't have questions about test 3 stuff, like, let's spend this few of the minutes right now just to attack a problem that we were confused about before. Is there something in particular, as you think back on test 1 or 2, that you didn't get right that you'd like me to talk more about? One thing comes to mind off the top of my head was solving inequalities involving, just solving inequalities, all right? Solving inequalities went badly for most people in here. Should we do that? Let's spend a little bit of time on that. Let's review inequalities. So advice I would give you in terms of how to study for the final exam, I would start with the tests and the quizzes, right? The tests and the quizzes usually inform my final exam the most, all right? So I'd start there. Then I would look at, like, my notes from the class. What do we cover? And so that would be my starting point. And then past that, of course, I would say look at homework, right? But so let's see here. Example, I guess I'm on example 7 today. Suppose you want to solve 3x minus 2 greater than or equal to 6 and give answer in interval notation. So this give answer in interval notation, this is going to be my instructions for all these problems, okay? So what do? Isolate x, right? So I should, add 2 to both sides? So we get 3x greater than or equal to 6 plus 2, which is 8, right? And then divide by 3, right? And if you want to, you can draw a number line. That might be helpful. Here's 8/3, right? Where does x? Greater than 8/3, right? So x is like over here somewhere, right? And so the picture is something like that in a number line. What's the interval notation for this? So solution, we do 8/3 included all the way to infinity. That's the answer. Right. Let's do another one. Let's do minus 2x less than x plus 6. So what should I do this time? Well, if I subtract x to the other side, I get what? I get minus 3x is less than 6, right? Now, and I heard divide by negative 3. Got to flip the sign, right? So divide by negative 3 flips less than to greater than. So we do x greater than 6 over minus 3, right? Which, of course, is minus 2. So we have x greater than minus 2. if I draw a number line to think about it, I've got minus 2, and x is greater than that, right? So it's like this. What's the interval? So solution is minus 2, not included, to infinity. So a sizable portion of you were already pretty good at these. Right? I don't mean to say the whole class is lost on these. A lot of you had these down pretty well. What confused you more were the inequalities involving absolute value. And, well, for that matter, solving the equation with absolute value also got you guys into some trouble. Right? So to remind you what's at stake there, I'll warm up with an equation, right? So like if you're going to solve 3x plus 8 equal to 10, absolute value of 3x plus 8 equal to 10, how do you do it? You really have to think about two separate equations, right? So there are two equations to think about here. The one is the one that you guys always get, which is 3x plus 8 equals to 10. What's the other possibility, though? Not minus 8, but 3x plus 8 equal to negative 10. Yeah. Or you could put the minus on the other side of the equation, but the point is either one side or the other of the equation has a minus, right? And so these are two separate problems, really. This gives us 3x is equal to 2. This gives us 3x is equal to minus 18, which gives us the solutions 2/3 or minus 6. So there are, in fact, two answers. All right. Now, I know we haven't talked too much about graphing, really hardly at all in this course about graphing, right? The only thing we've really graphed in here for the most part is what? Quadratics. As I recall, quadratics and lines, that's pretty much been it for us, right? In your next course, in the pre-calculus course, you'll do much more graphing, right? But just to give you a preview of that, this absolute value function looks, it's 0. This expression is 0 when x is minus 8/3. So for what it's worth, it's like 0 here, and then it's at 8 when x is equal to 0. So this is not the scale or anything, but it's something like this, right? And if you look at 10, that's roughly speaking. So this is 8, and what I'm graphing is y equals the absolute value of 3x plus 8. So just to give you an understanding of why we're getting the answer we are, it's because this 10 intersects the graph here and here. Where are those points? Those points are 2/3 and minus 6 for x. That's why you have two answers, because there's two places where that absolute value function reaches 10. All right? And so that kind of thinking is actually really helpful as you think about conceptually if you think about the graph of an absolute value function, it looks something like this, right? Roughly speaking, just being sort of generic, if we're looking at absolute value of some linear expression, the graph of it looks kind of like this, all right? There's some place it's 0, there's some place, it's something like this. And so if you ask the question, just think about this for a second. If you ask the question, where is like above the line versus if you ask the question below the line. If you ask what's above the line, what are the solutions? Well, like above the line, you've got here and here, right? Everything this way and everything that way. Above the line, there's two separate places where that's the case. Like there's two separate places where the black is above the red, right? On the other hand, over here, where is the black below the red? There's just one case, right? It's between here and here. So what I'm trying to tell you is when you're solving absolute value, if we have, absolute value of stuff less than some constant, right? Excuse me, greater than some constant, my bad. Then there are two possibilities. Either the stuff is less than minus c, or the stuff is greater than c. And these are two disjoint cases. And over here, if you've got stuff less than c, then what you're going to have is minus c less than the stuff less than c. So the way that you solve greater than, I'm an idiot. Oh, no, it's fine. So greater than, less than. My mind flips those sometimes. I don't see the difference, and that's the problem. Maybe you guys have too. So what I'm trying to say is there is a vast asymmetry in how we solve less than or greater than for absolute value. You have to be aware of this and treat these problems differently. Let me put some expressions in here and make this a little bit more concrete. I know my kind of sketchy pictures may not do anything for you. If they don't, I'm sorry. But I don't test you on this picture, right? That's just, I'm showing you how I think about it, but you don't have to think that way if you don't want. But we do all need to be able to solve these problems. So absolute value of 3x minus 2 less than 1. So the way to solve this problem is to understand what that means is minus 1 is less than 3x minus 2 is less than 1. That's all you got to do. A less than absolute value becomes a compound inequality in this way. And so then how do you solve something like this? Add 2 across it, right? Add 2. So we got like minus 1 plus 2 less than 3x less than 1 plus 2, which is to say 1 less than 3x less than 3. And then what? Trying to isolate x, right? Divide by 3. So we've got 1/3 less than x less than 1. Here's a number line picture for that. So you're between 1/3 and 1, right? X is up in here somewhere. So what's the answer in interval notation? Interval notation, we want 1/3 not included all the way over to 1. There you go. On the other hand, what if we're going to solve 3x minus 2 greater than or equal to 1? This is a totally different problem. There are two ways that you can make this happen. The one way you could make this happen is 3x minus 2 less than or equal to minus 1, or 3x minus 2 greater than or equal to 1. Either one of those conditions will make the absolute value greater than or equal to 1. So we have to solve these separately, all right? So this is 3x less than or equal to, add 2 to both sides, 1, right? This is 3x greater than or equal to 3. Divide by 3, x less than or equal to 1/3. Over here, x greater than or equal to 1. These are not both true at the same time. There is no single x on the number line which is simultaneously both less than 1/3 and greater than 1. These are disjoint cases, right? You cannot have a single x which does both of these. These are, like I said, disjoint cases. So here we have 1/3. Here we have 1, right? And so it's either x is over here or x is over here. This is x greater than or equal to 1. This is x less than or equal to 1/3. And so we have these two disjoint cases that are the solution, right? And so the interval we do minus infinity to 1/3 included, that's the 1, or what? 1 to infinity. And so that's the solution right there. This is not an accident, right? These two examples go together. Do you see what I did? It's the same expression, 3x minus 2 less than 1, 3x minus 2 greater than or equal to 1, right? Think about this. It's either less than or either less than 1 or it's greater than or equal to 1. That has to be everything. And indeed, that's what we see in the solution, right? 1/3 to 1 is the solution to example 10, but then everything outside of this open interval, namely minus infinity to 1/3, and then 1 to infinity is in the other one, because these are complementary problems. I did this on your test. I did this exact same sneaky thing on your test, the first test. So anyway, I just wanted to give you, a little just brief review of something that popped out as me as being an issue on test 1. Is there anything else you guys like me to review? We got time for like one more example. I'll let you guys go early. Or I should just let you guys go early. That's good? All right, well. Think about your previous test, though, for future classes. We should talk more. We'll have a review after the Thanksgiving.